Hi everyone, good afternoon and welcome to today's GCSE Maths live group tutorial, today on simplifying and dividing ratios. So welcome back, I can see lots of you joining us and welcome if this is your first time. I'm Tilly, I work for my tutor and this lesson today will be led by one of our top tutors, Molly, who's completed over 150 lessons with us on my tutor. She studies computer science and maths at the University of Bath, so it should be a really great lesson today. I'll be here throughout the session in case you have any questions about the My Tutor online school. And equally, if you have any questions about anything that Molly's going through during the lesson, just pop that in either the chat or the Q&A box and we'll do our best to answer those throughout the session. There'll also be some time for some questions at the end as well. So I'll just wait another couple of moments as a few more people join. Just to let you know, as normal, this session will be 1 hour, so we'll finish at 1:15 p.m. today. And if you're keen to join us for some other tutorials, we've got a busy timetable this week. So this afternoon, we've got another couple of lessons, which should be really great. We've got, let's have a look, we've got GCSE Physics at 2 p.m. and we've got GCSE Biology at 3:15. Brilliant, so looks like lots of you have joined us. So if you're all ready to go, Molly, let's get started.
Cool. Okay, let's go. Hi, everybody. I'm Molly, in case you hadn't guessed. And yeah, today we're going to be going over simplifying ratios and everything ratio, basically, which should be a good lesson. Yeah, I think ratios is one of the things that confuses quite a lot of people. It used to really confuse me when I was doing my GCSEs. So hopefully this lesson will make it make a bit more sense. So we're going to start right from the basics of what they are, what on earth they represent, and how to solve basic questions. We're going to tackle loads of questions and then go on to some harder examples, even throwing a bit of algebra in there. So let's jump straight in. So what actually is a ratio? The best way to think about a ratio is that it's kind of just like a fraction. So if we have the ratio 4:6, what that means is that for every 4, I always think about them as chunks. And I'll be coming back to this throughout the session, talking about chunks or pieces. And that should make sense as we go through. So this means that for every 4 of this thing that we have 6 of this thing. So for example, we could have, that was almost a really good circle. We could have a cake that is split like this. Oh gosh, if you just want to pretend that these are even, that's so bad, right? Those are 10 slices, right? And if we have like for every 4 of these, there are 6 of these blue ones. You get the idea. And what this represents is that there are 4/10 pink and 6/10 of the blue. We always add these numbers together because this shows us what the total number of chunks are. Now what we can also see is that we can simplify these just like we could simplify a fraction. So you can divide both the left and right hand side of the ratios by the same number. So here we can divide them both by 2. So this is exactly equivalent to the ratio 2:3. And we can see that here for every 2 of these, there's 3 of these. And what I'll do is I'll demonstrate that by kind of drawing these little separators here. So in this section, there's 2 pinks, so there's 3 blues, and here there's 2 pinks, so there's 3 blues. So that's how we can simplify a ratio, just like we would a fraction, really. And we can see that then this is the same as 2/5 and 3/5. So whenever you think of ratios, it kind of helps to think about fractions as well. If you don't understand this, don't worry, it will make a lot more sense when we do some questions and it's not just me drawing awful circles. It's basically just a way of showing that how something is split. So I'll give you one more kind of example just to demonstrate that, and then we'll jump straight into some questions. So if we said something like, my brother and I share £100 in the ratio. Ooh, if I could write, that would be great. In the ratio, let's say 2, 3. This means, so it's always in the way that you read it. So my brother is the 2 and I'm the 3. I get more because I'm older, right? So this means that for every 2 chunks, so maybe for every £2 my brother gets, I get £3. That means that for every £20 my brother gets, I get £30. Just a kind of a scalar thing. It's just for every 2 of something he gets, I get 3 of it. Now, this actually leads us quite nicely. We can solve this question. This question might be, how much money do I get? Well, we can work that out. I always kind of think about this £100, if you want to draw a diagram. Let's say that this box, this rectangle represents our £100. That's what this is. And it's been split in the ratio 2 to 3. So what we do is we add those together to work out how many chunks there are total. Because my brother's getting 2 chunks, I'm getting 3 chunks. So that means that between us, it's split into 5 chunks. So then we split this 100 into 5. This means that there are 5 chunks here of equal size. They're all equal chunks, and my brother's going to get 2 of them and I'm going to get 3 of them. So now all that we need to do is work out how much each of us gets. So if there are 5 equal chunks that make up £100, hopefully you can see that the calculation that we're going to want to do is 100 divided by 5, and that's going to give us 20. So that means that each one of these chunks here represents £20. So then my brother is going to get 2 of those chunks. So that's £40. And I'm going to get 3 of those chunks. So that's £60. And hopefully that kind of makes sense a little bit. I'll just check the chat. Yes, I can get shapes on the thing. That's actually a good shout. I might do that from now on so that you don't have to see my horrible circle drawing abilities. Hopefully that makes sense. Just shout if you have any questions about this. Hopefully it'll make sense as we go through more. But this is just explaining, because you might have seen before that you add the ratios, divide it and multiply. But this is kind of explaining why. Always think about it in terms of these little sections. If so-and-so gets this much, so-and-so gets this much. So a quick note on simplifying ratios. We're going to look at the reverse of that question. So, for example, it could be my brother gets £40 and I get £60. In what ratio have we split the money? So we already know what we're expecting this answer to be because it's the reverse of the previous one, but I'm going to show you how we'll get there. So the first thing that we do is we write it out in the most basic, simple way we possibly can. So if my brother gets £40 and I get 60, that means that if my brother gets 40 chunks, I get 60 chunks. If each chunk is £1. Now that is a perfectly acceptable ratio. We've split this money in the ratio 40-60. But let's make it a bit simpler because nobody likes working with big numbers. It's like if you had the fraction 40 over 100, you'd want to simplify that. Probably, unless you're a monster. So let's have a look at how we can simplify it. Now, it's what I said before. We can divide each side by the same thing, and that's totally allowed. So the most obvious one to me here is that we can divide both by 10. 40 and 60, both multiples of 10. So we'll do that. And we see that we get 4 to 6. Now, this is the same thing. My brother gets £4, I get £6. That just happens 10 times. So this is the same ratio. And we can actually go one better than that. We can divide both sides of this ratio by 2. and we'll end up with 2 to 3. Now that can't be simplified anymore. 2 and 3 are both prime. There's nothing that's going to go into both of them. So that's our final answer to this question. The ratio is 2 to 3. Actually, this question that I've worded rather poorly, this is a perfectly acceptable answer. Normally the question will say, what's the ratio in its simplest form? All of these ratios are equivalent. They mean exactly the same thing. Yes, we are doing triple ratios. I know that these are really easy at the moment, but just in case, because sometimes people struggle with the actual concept of them, these will be getting harder, don't worry. Okay, yeah, so seeing as people are getting that, let's jump straight into some actual more exam style questions. So the first one, we'll start with quite an easy one. We'll get into harder questions. So this is a classic kind of word question. A piece of wood is of length 45 centimetres. The length is divided into the ratio 7 to 2. So for every 7 centimetres on this side, there's 2 centimetres on this side. So we want to work out the length of each part. So I'm going to do it kind of, I'll do this first one with a diagram and then I'll kind of go away from the diagram. So here's our piece of wood. It's divided here so that this section has 7. Pretend they're equal. And this section has 2 and all of those are equal. So we know that altogether we have 9 chunks. So that's what we've done. 7 plus 2 equals 9. Then we want to know how much each of those chunks are. So we do 45 divided by 9, which gives us 5. So that means that each of these chunks are 5 centimetres long. So hopefully that makes sense. And then we've just got to work out the length of each part. So our first part here, the 7 centimetres, sorry, not 7 centimetres, the 7, this kind of left chunk, is going to be 5 centimetres times that 7 that we've got there, which is equal to 35 centimetres. And then we can have a look at this chunk here, which is 2. So it's 2 lots of those. I'll write it the same way around. It's that 5 centimetres times 2. 2 lots of that 5 centimetres, so 10. And what we can see is that these two add up to 45, which is perfect. That's what we wanted. So we've split that 45 centimetre piece of wood. Yeah, brilliant. Everyone seemed to get that, which is awesome. So from now on out, unless someone asks me to do it again, I won't do the diagrams. I'll just kind of do the maths part of it. So we'll do another simple one like this. If you're finding this easy, see how quickly you can send me the answer to this one. Alex and Ben were given a total of £240 and they shared the money in the ratio 5 to 7. Work out how much money Ben received. So what this means here is that 5 is Alex and 7 is Ben. So we can work this out. 5 plus 7, there are 12 chunks. So how much is each chunk? It's going to be £20. And Ben received 7 of those chunks. So Ben received 7 times 20, 7 of those chunks, £140. Now I raced through that, so let me know if that was too fast, but the consensus was that it was too. Yeah, brilliant. Everybody got that really nicely. Cool. I'll try to find a harder one on here. If not, I've got a different kind of hard. Yeah. Here's a slightly more tricky question. So, Melissa is 13 years old, Becky is 12 years old, Daniel is 10 years old, and they share £28 in a ratio of their ages. So the ratio now is going to be 13 to 12 to 10. So for every £13 Melissa gets, Becky gets £12 and Daniel gets £10. And then Becky gives a third of her share to her mother. So how much should Becky now have? There's a couple of ways that we can think about this actually. I'll show you the most obvious way first, and then like a tiny little shortcut that we could do. So the most obvious way is going to be to say, Well, let's just do it in our normal ratio way. So we add up all of the parts of our ratio, which is going to give us 35, and then work out how much each chunk is worth. So we do that £28 and divide it by the 35 chunks that it's split into. Now, if this was on a non-calculator, this looks pretty horrible. We can simplify this fraction. We can in fact divide the top and the bottom of the fraction by 7 to give us 4/5. So each of these chunks is 4/5 of a pound, or 80p. So hopefully that makes sense. The chunk can be less than 1. The chunk can be a decimal, a fraction. So now we just do exactly the same thing. So we'll work out how much Becky gets. And she gets 12 of these chunks. So it's 12 lots of the 4/5. If we want to do this without, I'm going to do this all without a calculator, staying working in fractions, because I think it feels a bit more uncomfortable, especially when we're talking about money, but you'll see how it works out. So when we do this, remember this is like 12/1. So we do 12 times 4 and 5 times 1. So this is going to give us 48/5. Without converting that to a decimal, we don't really have any idea about how much that is. But what we do know is that she then gives 1/3 of her share to her mother. So she's left with 2/3, right? If you give 1/3 of something, if you have a cake and you give 1/3 to someone, you're left with 2/3 of the cake. So what she has is the money that she has and 2/3 of that. And when we do this multiplication, we're going to get 96/15, which is not a nice number, but we can simplify that even more, make this nicer. If you want me to go through it, just shout, but for now, I'll just do it on here and show you that you'll get 6.4. So that's £6.40. And that's what she gets. If that way was a little bit confusing, you could have worked this out here. So the amount of money that she would get before she gives any to her mother. And this is going to give you £9.60. And then you can work out that the 1/3 that she gives is £3.20. So she's left with the rest, £6.40. Someone's a bit confused with the 2/3 part. So 48/5 is how much she has, £9.60, but we'll keep it as that fraction. And then if she gives 1/3 away, she's left with 2/3. So we want 2/3 of that money that she has. And whenever we say of, it's a multiplication. 2/3 of 48/5 is 2/3 times 48/5. Hopefully that makes sense. Like I said, you can make it decimals here and then think about it. That's totally fine. This is just slightly less calculation for you. And this is kind of showing you a non-calculator way. Now I'm going to show you another way. If you understood that method, brilliant. Maybe try to kind of understand this one. This just makes it a little bit quicker for you. So if you're getting the hang of this, this slightly more, it's weird because it's more advanced, but it actually makes the question kind of simpler. Basically, if they share it in these chunks, 13, 12, 10. Well, let's think about Becky's chunk, right? So this is Melissa, this is Becky, this is Daniel. Becky's getting 12 of those chunks, right? And she gives 1/3 of that to her mother. So what's really happening, if we kind of split this down further, is that Becky's getting 8 chunks and her mother's getting 4. Because, sorry, I'm about to sneeze. Excuse me. Because if she's 1/3 of 12 is 4, right? So say you've got 12 chunks of money, and in this case, that's 12 lots of 80p. If you've got 12 of those chunks and you give 1/3 away, you're giving 4 away. So what we can kind of make this ratio now, when I say kind of, we can, is like this. Replace that 12 with an 8 and a 4. And what we have now is, this is Melissa, this is Becky, this is her mum, and this is Daniel. So now it's a 4-way ratio, but what we're going to do instead is that once we get this 4/5, We multiply it by 8 instead, and we immediately have our answer. We don't even need to think about the third. We've already thought about that third. So hope someone said bless you, thank you. Yeah, this method is more confusing and people probably prefer the first one. But if you're someone who loves maths and loves shortcuts in maths, like me, basically if you're a maths nerd, which is cool, then this method, I don't know, it's quite interesting. And it focuses on the ratios more. So maybe this gives you a better idea of ratios. Yeah, hopefully. If not, ignore it. If you don't like it, honestly, ignore it. Hopefully that makes sense. Someone said, can you explain that method again? I might come back to it later or try to explain it in a different question maybe. For now, I'll try. This bar wants to let me go to the top. Brilliant. See, all of these are quite, here we go. Let's do this. Because this one, I think I can possibly explain both ways as well. So I'll try explaining this one both ways. So I'll do it the easier way first and then the harder way, but that makes the question easier. Maybe the more complicated to explain way, but it still makes it easier for you. So let's just do this question in the natural way. So Anne and Bob shared £240 in the ratio 3 to 5. So for every £3 Anne gets, Bob gets 5. Anne gave half of her share to Colin, and Bob gave a tenth of his share to Colin. So what fraction of the £240 did Colin receive? So let's just do this first of all in the normal way. So 3 plus 5 is 8. 240 divided by 8 is 30. So each of these chunks is £30. Now Anne gets 3 of those chunks. So Anne gets £90. And Bob gets 5 of those chunks. So Bob gets £150, right? So this is how much money they each get. And then Anne gives half of that to Colin, so that's £45. Bob gives a tenth of his to Colin, so that's £15. Hopefully you can see why I've just divided this by 2 and then divided this one by 10, which is £60, so that's how much Colin gets. And then what fraction of the £240 did Colin receive? Well, he received 60 of the £240, and then we can just simplify this. We divide the top and the bottom by 60, we get 1/4. Now that was really quick. I'm very aware of that. Let me know if you want me to explain that again, but a bit slower. Oh no, loads of people got that, awesome. Okay, yeah, well done. Cool. Yeah, so the fraction here is 1/4. Now I'm going to show you this sneaky, just thinking about the ratios method. So, same question, I've just pasted it again. We're going to think about it just in terms of these ratios, these chunks. And what we're going to do here, we're not going to calculate anything. We're not going to calculate any amounts. We're not going to know how much Anne gets, how much Bob gets. We're not even going to know how much Colin gets, because the question's just asking us for the fraction. Don't worry if you don't understand this. It is a bit more confusing, but I don't think it's as confusing as you think it might be, hopefully. So here's, right, I'll stop blabbering and just actually explain it. So we've got this here, Anne and Bob. Oh, they've beautifully named them A, B, and C, so I don't have to write out names. So Anne gets 3 chunks, Bob gets 5 chunks. Now, Anne gives half of her share to Colin. So what's really happening, if we break this down, is that Anne actually gets 1.5 chunks and Colin gets 1.5 chunks, right? If you have 3 chunks of something, if I have 3 cupcakes and I give half of them to Colin, then Colin gets 1.5 of my cupcakes, right? That's half of 3. It's half of the cupcakes I have. That's if we're imagining that each of these chunks is a cupcake, right? And if we look at what Bob does, well, Bob has 5 chunks. Bob has 5 cupcakes, and he gives a tenth of those cupcakes to Colin. So he gives half a cupcake to Colin, right? That's a tenth of 5. So what really happens here is that Colin's getting half of a cupcake. So Bob's getting the rest. Bob still gets to keep 4.5 of his cupcakes. And now if you look at this, we've kind of made this into these new ratios of chunks. And we're just going to combine them. So what actually happens is that Anne gets 1.5. Bob gets 4.5 chunks. Again, these cupcakes, right? And Colin gets 1.5 cupcakes from Anne and half a cupcake and 0.5 cupcakes from Bob. So Colin walks away with 2 cupcakes. And then, oh my God, look at this. We've made it into ratios. What? Mental. So what we've done here is we've just fiddled around, taken out the chunks that they would give Colin and made it into this new 3-way ratio. And now we can just think about these straight away as a fraction. You know how, I'm just going to write this up here as an aside. You know how if I said we have the ratio 2 to 3? Well, what this one is really representing is 2/5, right? Because if you've got 2 chunks and 3 chunks and you take 2 of them, that's 2 out of the total of 5. So that's exactly what we're going to do here. If you add up all of these chunks, you get 8. And Colin's got 2 of them, 2 of those 8 chunks, which is a quarter. I'm going to check the chat, see if anybody follows. Yeah, you could absolutely multiply everything there by 2 to avoid getting decimals. That's quite sensible. Yeah, you can totally do that. 2 viewers just messaged, wow. Okay, people are kind of getting this method, which is good. Hopefully you can see that this took a lot less working than this did. And I didn't even have to think about amounts. So if this was a horrible number, this is the thing, it doesn't even matter that it's £240, which I think is really cool. That number could have been £1 million. And the fraction that Colin gets is still the same because we're not even thinking about it. So really we don't need this £240 at all. And hopefully that makes some sense. Cool, people are saying that the second method actually helped, yay. This kind of question here is possibly more like higher, possibly, especially here because they could have said something here like they shared an unknown amount and then you have to use this method. It's up to you. Yeah, if it was £1 million, they would be rich. I wish I got £250,000. Right, okay, I'll carry on with some harder questions. And at the end, feel free to just whack it on the Q&A if you want to come back to another question like that. And I can come up with one. So, as promised, I'm going to throw some scary algebra into the mix, because who doesn't love a bit of that? So these look horrible just because it's got an unknown in it, but it's totally not. We just use what we know about ratios and it becomes totally fine. So here is what we do. There's a couple of ways of thinking about these. I'll show you kind of the most natural way of thinking about this one, and then a general method so that if the numbers get a bit harder, we can just apply our method. So I always write them one over the other, right? So we've got that the ratio 4 to 8 is exactly the same as the ratio V to 6. And there are several ways that we could think about this. Basically, what we want to do is make sure that these numbers are both the same, because then we can set these equal to each other. So we can kind of go along this path. So here's what I would do. Divide this one by 4. And then we see that this is the same as the ratio 1 to 2. And keep this as it is, V to 6. And then we want to make this second one here, this 2, into a 6. So let's multiply the whole thing by 3. So this is the ratio 3 to 6. This is the ratio V to 6. And look, now these are equivalent, so these have to be equivalent. So V equals 3. So hopefully that kind of makes sense on there. So that's the kind of, this to be fair would work with almost any. Sometimes you'll have to fiddle around with this one a little bit as well, and we'll get like 2v or half v or something. But that's the most kind of basic method. Now the other way that we can do it, which is especially helpful if you have a calculator, is we'll do the same thing and we'll write 4 to 8 and v to 6. And this is nice if you have a calculator and or if the numbers are horrible. And what we can do is say that because these ratios are the same, we can kind of make fractions that are the same. Now there's a couple of ways that we can do this. We can either say that this over this is equivalent to this over this. So we just say that that's basically, it's just saying that the ratios between them are the same. If you divide one by the other, they come out as the same thing. Or we can do it like this way and say that this over this is equivalent to this over this. Whatever you want. We're going to do it this way. So if you want to just remember one method, if you don't understand and you just want to remember going across. So here's what on earth I mean. V over 6 equals 4 over 8, right? I've just taken, it's important that you go in the same direction. So V over 6 is the same as 4 over 8. And then we just multiply it by 6 to get V by itself. So we do V equals 4 over 8 times 6. And then we can work this out in several ways. I would personally simplify this fraction first, maybe. 1 over 2 times 6, so half times 6, that's 3. And bish bash bosh, you've got the same answer. Okay, cool, yeah, people are saying that that's quite simple, which is good. We'll go over a couple of more of those, because I know that even when it's simple, it can be quite scary and overwhelming when there's letters thrown in there. Trust me, I get it. You take something that you think you're really happy and comfortable doing, someone throws an X in there and suddenly it looks horrible, right? So we'll go over a couple more and then get even more advanced if we wish to do so. So yeah, here we've got the ratio 7 to 5 is equivalent to 6 to n. We want to find the value of n. So I think here it's much nicer to do our second method that we did, because we're going to have to do quite a lot of fiddling to both of them. Well, actually, I'll show you that method as well, just in case people prefer this one. So we've got 7 to 5 and we have 6 to n. I'll colour code it again for you. So what, if in doubt, do something that's a factor of both of these. So because we want these to be equal, it's kind of like with fractions. You know, if you have like 1/7 and 1/6 and you want to add them, you'd make them both be something over 42. That's kind of what we want to do. Imagine these as the denominator that we want to make the same. So let's multiply this first one by 6 and we get 42 to 30. And then we'll multiply this second one here by 7 to get 42 to 7n, right? And now these are the same, so these have to be the same. So 7n has to be equal to 30. So n is equal to 30 over 7. You don't need it to be simplified any more than that. Yeah, 30 over 7, brilliant. Yeah, it will be a huge decimal because anything over 7 is going to be reoccurring. So it's a horrible decimal, which is why we like fractions. Cool. Yeah, someone said as well about cross multiplication. I'll show you what that one is. And it's basically the same fraction method, but in disguise. So 7, 5, 6, n. Cross multiplication basically means that these two multiplied is the same as these two multiplied. And we actually get the same thing. 7 times n is 7n. 5 times 6 is 30. Our division method just sometimes makes it easy. And this is essentially our division method, because we're saying that our division method, if we go like across like this, so I'll box this off. This is one method. Another method is saying n over 6 equals 5 over 7. And hopefully if you kind of fiddle around with, well, if you multiply this one up by 7 and this one up by 6, you're going to end up with the same thing, 7n equals 30. or just you can go straight from this to saying that n equals 30 over 7. I know that that's a load of different methods. My point is there are loads of ways of doing this. Do whichever one you understand the best. So yeah, we'll go over a couple more. Show you the nicest ways. Let's have a look. Let's do this one. The ratio x10 is equivalent to 9 to 6. So from now on, unless someone tells me differently, feel free to just shout and ask me to do a different method. I'm just going to do cross multiplication. So thank you to whoever pointed that out. I think that's probably the simplest one to do. And also shout if you don't understand why it works. I think maths is just as much about understanding why than just being able to blindly apply a method. So we're going to write out these ratios, x to 10, 9 to 6, and we're going to cross multiply. So these multiplied, 6x is equal to these multiplied, 9 times 10, 90. So then to find out x by itself, we're going to divide both sides by 6. So we get x is equal to 90 over 6. And now that's a perfectly satisfactory answer. We're just going to make x a bit simpler because we can. So to work out this, what I would do is first of all divide by 2, because we know that they both divide by 2, right? So this is equal to 45 over 3. I've just divided the top and the bottom by 2. And then I can see that these are both divisible by 3. So on the bottom, I'm going to get 1, or I can just see that because they're both divisible by 3, I just do 45 divided by 3, which is 15. So x is equal to 15. Check the chat, see. We got it. Awesome, cool. I'm going to do some harder ones in a minute, don't worry. Someone's just asked to explain this method. Sure, I'm just going to explain why cross multiplication works. So the reason is kind of comes from the ratios that I was explaining initially. So if we have, right, I kind of want to explain why algebraically. Stop me if this is getting too confusing, but hopefully this will make it actually easier. I'm just going to say that A to B is the same as C to D, right? And then hopefully this will kind of prove it to you. So we say that using my method that I said before, we say that this over this is equal to this over this. So that one, it's hard to explain why. That's just because that's how ratios work, right? The ratio of these numbers is kind of the same as the fraction of them. So we say A over B is equal to C over D. That's the method that hopefully you're comfortable with that I was saying before, where we're just looking at the ratios of them. And then we're going to multiply both sides by B to get rid of the B here. So then we see that, scroll down a bit, we see that A, and when we multiply this by B, remember we just multiply the top. So we get that A is equal to BC over D. And then in a really similar way, we're going to multiply it by D. So we see that AD equals BC. So we get AD, those two multiplied, is equal to BC, those two multiplied. Does that make a bit more sense as to why cross multiplication works? Hopefully. Yeah, cool. Nice. Okay. Yeah, I'm going to do more examples. I know that that looks horrible because I've just whacked 4 letters in there, but sometimes you've got to do that to kind of prove to yourself that something really works. I'll do another example for you guys. I'm just going to do one more simple one and then we'll do some... Oh, wait, am I? No, actually, because I only have 5 minutes before questions, I'm going to do one like this. It's exactly the same thing, to be fair. So let's look. So this time we've got the ratio n plus 7 to 7 is equivalent to 4 to 9. Well, we're just going to do exactly what we've done and not be scared because it's an x plus 7. We're just going to write them out like this and do our cross multiplication. So 9 lots of n plus 7 is equal to this. So 7 times 4. And then we're just going to solve this like an algebra equation. which is exactly what it is. We'll expand out the brackets here. 9n plus 63. I've just done 9 times n and 9 times 7. That's just how we expand out brackets. Is equal to 28. That's what 7 times 4 is. Then I'm going to subtract 63 from both sides. So I'm going to get 9n is equal to minus, so sometimes that value of n can be negative, minus 35, I think, I hope. And then we get that n is equal to minus 35 over 9, which feels like a really horrible solution. I guess, yeah, loads of people got that well done. So that is a horrible solution, but there you go. Sometimes they're negative fractions, so don't be scared if one like that happens in an exam. Okay, cool. I'll go over one more like this, and then just in the last 5 minutes, just introduce you to another kind of, another type of question, basically, another type of tricky question that is often asked. So, here we've got a's in 2 places. This is what makes this not as nice. The ratio 10 to a is equivalent to 8 to a plus 10. So again, we could do several methods. We could make these both be equal to something. So for example, 40, both go into 40, and then we'd have an equation in terms of our a's. But we can also do cross multiplication. So we may as well do that. So we'll start by, as we always do, writing them out. And then we'll cross multiply. So 10, I'm not doing the arrows this time, so let me know if it's 10 lots of a plus 10. So going this way is going to be equal to this way. So 8a. Right, so now I'll just multiply out this side. So we get 10a plus 100. So multiplying both bits by 10 is equal to 8a. Then I'm going to move my a to this side, so subtracting 8a from both sides gives us 2a plus 100 equals 0. Take the 200 over to the other, take the 100 over to the other side. 2a equals minus 100, and then divide by 2 to get a is equal to minus 50. So if you were confused about any of the algebra there, maybe have a check back at my previous algebra videos, but hopefully that makes sense. Yeah, perfect. Cool. Someone asked, should we take notes? You can if you want to. These resources are also available online, and also this video will be recorded and uploaded online, so you can watch it back. So whatever works best for you. Okay, I've only got kind of 3 minutes before questions, but I'm just going to show you one like this. I'm going to show you this one actually. These are 3-way ratios, and you'll understand what that means now. So basically, we've got the ratio of dogs to fish, and we've got the ratio of fish to cats. And from that, we want to find out the ratio of dogs to cats, right? We're obviously not going to know, we're not going to be able to work out the numbers of these because we could have, like, say the ratio ends up being 1 to 2. That could mean we have 1 dog, 2 cats, or it could mean we have 2 dogs and 4 cats, you know? But we just want to work with the ratios. So these are quite interesting, but you can think about them in a really nice way, I think. So we've got the ratio of dogs to fish here. And I always kind of write underneath what it is that I'm looking at. And then we've got the ratio of fish to cats. And we always want to kind of combine, like smush together, basically, the ones that are the same. So these are both fish, right? So if we can make these the same number by manipulating these individual ratios, we can smush them together and make it just one ratio with 3 things in it. So we want to do something now, find something that's divisible by both 10 and 6. So I'm going to choose 30, right? I'll make these both equal to 30, and then we can smush them together. So to make this one equal to 30, I'll do this in a different colour. We're going to multiply by 3. So we get 3 to 30. So for every 3 dogs, there are 30 fish. And I'm going to keep writing what they are underneath. And this one, to make 6 equal to 30, we times it by 5. So we times the 1 by 5 as well. So for every 30 fish, there are 5 cats. And now these are equal numbers and they're both numbers of fish. So we're going to combine it. Like I said, we're kind of like slotting them together. So then what this becomes is 3 to 30 to 5, right? Dogs to fish to cats. Literally imagine like overlapping those two 30s. Become one ratio. So that means for every 3 dogs, there are 30 fish and there are 5 cats. And now because we just want the ratio of dogs to cats, we're going to ignore the fish because we're not interested in those. And we're left with a ratio, 3 to 5. That's our ratio of dogs to cats. For every 3 dogs, there are 5 cats. Hopefully that one makes sense. Cool. Okay, yeah, people got that, so that's really, really good. Okay, nice. So now we have 15 minutes for questions. Feel free, if you don't have any specific questions, just let me know what you'd like me to go over more.
Cool, yeah, someone just asked about the videos and where to find them. So yeah, as Molly said, this has been recorded and will be uploaded, as have all the past videos. You can find those on the My Tutor YouTube channel. So if you just go to YouTube, type in My Tutor, we have a channel with all the past recordings and some shorter videos as well related to the topics that Molly and our other tutors have gone over. So those should be helpful for you guys. Yeah, so just chuck any questions in. Let's have a look. Molly, someone asked, where do you get the exam questions from?
So these ones that I got here are from this website called Maths Made Easy. I've talked about this one before. They have loads of like worksheets on basically any topic. So what I type in is I type in GCSE Maths ratio questions, and I think it was pretty much the first link. These ones here were from the TES website, which basically is resources. Oh my God, I don't know why it's on Yahoo. Please don't judge me. Here, basically, if you search in TES, they're like teaching educational resources. So they're mostly for teachers, but a lot of them are free to download. So if you find any that are free, you can just download them and use them yourself. So that's where I found these documents here.
Brilliant. And someone's asked, will there be languages sessions? We're working on adding some new subjects in, so we can't say which those will be yet because we're still working on that, but just watch this space for that. We'll let you know in these tutorials, and also on the site you'll be able to see what's coming up. So thank you for all the suggestions. Someone asked way back when we were doing the question on Colin and the gang, I can't remember what the other students were, if we could go over another one like that. And then a couple of people have said sort of throughout, can we do some harder questions? So for the last sort of 10 minutes, would you be able to do that, Molly?
Yeah, sure. I'll find some difficult questions. Okay, cool. Yeah, one like that. I assume people mean ones like this. So I'll try to, gosh, I don't know if I can find one. I'll just see if there's one on here. If not, I'll make one up basically. And yeah, a lot of these are really difficult. So, oh, okay. I think this question, just by glancing at it, looks similar, I think. So we'll have a go at this one and see. And then some of those questions on that document are quite difficult. So we'll do this one and then we'll just do some final questions from that document. So, right. On the table, yes, this is perfect. This is exactly like that question. So on the table, there are some sandwiches. The ratio of sandwiches with white bread to brown bread is 10 to 3. So for example, if there are 10 white bread sandwiches, there are 3 brown bread. If there are 20 white bread, there are 6 brown bread. Out of the sandwiches that are white, 2/3 are vegetarian. Out of the sandwiches that are on brown bread, half are vegetarian. What fraction of the sandwiches are vegetarian? Now, this is exactly like the Anne, Bob, Colin question. So in this case, instead of giving money to Colin, we're making them vegetarian, right? That's our kind of divider. So that's what we're going to have a look at. Now, in this case, we don't know how many sandwiches there are. So this is exactly what I was describing, where you will have to do it using this method. So we're going to write out 10 to 3. So these sandwiches here are the ones that are white bread sandwiches. 10 of them out of these 13. So 2/3 of those are vegetarian. So basically 2/3 of the 10 sandwiches. Now that's quite a hard thing to do. So we're going to scale this up and make it something that we can do 2/3 of. This is what someone said before. We could make this horrible fractions, but I'm actually going to scale this up first. So let's times it by 3. Let's make it 30 to 9. Okay. So now we can see that, so these are the white bread. If there are 39 sandwiches, 30 of them are on white bread. So 2/3 of these are vegetarian. So we know that 20 of them are vegetarian and 10 of them aren't. So I'll just put not vegetarian and vegetarian, right? And then we can do the same here. So for these 9 brown bread sandwiches, half of them are vegetarian. So I'm not going to bother scaling this because half is a decent one for us to do. So this is 4.5 to 4.5, right? 4.5 of these sandwiches are not vegetarian, and 4.5 of them are. So now what we have is this kind of strange ratio here, where we have 10 non-vegetarian, 20 vegetarian, 4.5 non-vegetarian, and 4.5 vegetarian. The first thing I'm going to do is scale this up. So we can kind of imagine this in some sort of weird ratio at the moment. And we'll multiply it all by 2. We could have done this at the start. We're going to do it now to get rid of these horrible fractions. So this means that 20, 40, 9, and 9, right? So we've got 20 non-vegetarian, 40 vegetarian, 9 more non-vegetarian, and 9 more vegetarian, right? And now we just combine these. So we look at these going together. So our non-vegetarian, there's 29 of them. And then we look at these going together, so our vegetarian ones, there are 49 of them. So now this is our ratio of meat sandwiches, or non-vegetarian, to vegetarian. So now we just need to work out what fraction of that is. Well, if we have got 29 non-vegetarian and 49 vegetarian, then we've got 78 sandwiches total, right? That's what 29 plus 49 is. And 49 of them are vegetarian. So 78 of our sandwiches are vegetarian. Yeah, brilliant. A couple of people got that, which is really, really good. Did this method make sense? Does anybody want me to go over this again? I'm going to do some that are like slightly different to this, but they're still difficult, I think.
Someone's asked, would that be a grade 9 question?
I would have thought so, yeah. It would be up there. It would be at least a 7, 8 question.
Cool.
Yeah, so this is really hard stuff. So if you're understanding this, that's fantastic. And if you're not, maybe give it a watch again, have a think about it yourself, because these questions are doable. Even if you think you can't, you 100% can. Yeah. Okay, we'll have a look. We've got 5 minutes. I'm going to have a look at something like this. Yeah, we'll do this. Gosh. Right, hang on. Am I going to do this? Okay, yeah, I'm going to do this one because this one initially confuses me. So this will be fun, and it's a good example of how you can't always see the answer straight away. So again, they've given us lovely ABC names. So the ages of Adam, Ben, and Caleb are in the ratio 5 to 7 to 11. Next year, they'll be in the ratio 8 to 11 to 17. How old are they all now? So this is a really difficult one. Because they could, for example, now be 5, 7, and 11. But then next year, their ratios would be 6, 8, 12, right? So that's not quite right here. So I think what we're going to have to do is call these kind of A plus 1, B plus 1, C plus 1, I think. This is quite a difficult one. I can see how we can do it via trial and error, but I'll try to do it without that. So 5 to 7 to 11, this is the ratio A to B to C. So A, B, and C, excuse me, are what we're trying to find out now. And then this is what we're trying to find out kind of eventually, if that makes sense. So there are a couple of ways I can see to do this. One thing to be would be to express this ratio in the form A plus 1 to B plus 1 to C plus 1, right? Because they're all going to have aged 1 year. And then we can do something with these. So what I'm going to do is I'm going to section off like a part of these. So we're going to forget about Caleb for now. Sorry, Caleb. We're just going to think about the ratios of Adam and Ben. So Adam and Ben now are in the ratio 5 to 7, and next year they'll be in the ratio 8 to 11. So we're going to do cross multiplication of both of these and basically come up with some simultaneous equations. So this is a horrible question, right? It includes so many things. So we've got, this one's going to give us 7a equals 5b. That's just doing cross multiplication here. And this one is going to give us 11 lots of a plus 1 equals 8 lots of b plus 1. Are people kind of with me so far? This is a really, really difficult question. And this might not be the most efficient method. This is the first one that kind of came into my head, basically. So now we'll make this look a bit nicer. We'll expand out these brackets. Sorry, that was supposed to be an 11. I just wrote that really badly. I'm conscious of time, so I might be going a bit too quickly. Do let me know. Yeah, this question would be a grade 9, I would have thought. So now we're going to make these somewhat nicer. We'll make them more like our kind of familiar simultaneous equations. So we'll make this 7a minus 5b equals 0, and we'll make this 11a minus 8b equals minus 3. Hopefully you can see where I got that. So here I just subtracted 5b, and here I subtracted 8b, and I also subtracted 11. Maybe just watch this back and have a think, but I don't want to dwell too much on the algebra. So now we've got these two simultaneous equations to do. So I'm going to write these out. So 7a minus 5b equals 0. Oops. Right. 7a minus 5b equals 0, and 11a minus 8b equals minus 3. So hopefully people are still following this. So now what we're going to do is just solve these simultaneous equations. So I'm going to make the b's be equal. I'm going to make them both be equal to minus 40. So with our first equation, and if you're not following this, I did a session on simultaneous equations last week, so go and have a look at that. So I'm going to make this equation multiplied by 8, and I'm going to make that therefore 56a minus 40b equals 0. And this equation I'm going to multiply by 5. So this becomes 55a minus 40b equals minus, lost my train of thought there, minus 15. And now I'm going to do, call these equations 3 and 4. I'm going to do equation 3 minus equation 4, giving me 56a minus 55a is a, minus 40b minus minus 40b, they cancel out, and 0 minus minus 15 is 15. And now we've got the solution that a is equal to 15. So Adam is 15 years old. And that's basically solved the whole thing for us. Because now if we look at this ratio, I'm just going to have to transfer this. Oh, I'll write it up here. So now we've got this ratio 5 to 7 to 11, and we know that Adam is 15. So we can scale this whole thing up. 15 to 21 to 33, and these have to be their ages. So Adam is 15 years old, Ben is 21 years old, and Caleb is 33 years old. And if you kind of want proof of this, well, let's think next year, right? They're going to be 16, 22, and 33. And this ratio, if we divide everything by 2, is equivalent to 8 to 11. Oh, sorry, I meant 34. Sorry. Caleb's also aged. He's not some sort of weird non-aging person. 8 to 11 to 17. And that's the ratio that we were given there. So that is a very difficult question. But hopefully you can see that the main thing to note is that I did not know how to do that question when I put it on there. I just kind of thought about it in this way, thought, well, these have to be the ratios. If I express them as A to B to C and A plus 1 to B plus 1 to C plus 1, we can work it out. And I actually cut it down to just these 2-part ratios. And then just saw what I could do with it, basically. So a lot of these are just kind of, a lot of stuff, a lot of really difficult word questions are just writing down stuff that you know and seeing if you can do something with it. I hope that made sense. Yeah. And I've just run over, so.
Brilliant, thanks Molly. And everyone remember that if you're still confused about anything Molly's gone over and want to have a refresh and really go into it, you can rewatch the tutorials to do that and try the questions yourselves again. So thank you so much for coming today and for all the questions, and thank you very much Molly for a fantastic session. If you want to join us for some more tutorials today, we've got GCSE Physics Introduction to Waves at 2 p.m. and GCSE Biology Digestion at 3:15 p.m. And you can find links to those tutorials both on your emails and also on the site. There are links to those tutorials. So thank you very much for coming, and hopefully see you guys in another session soon. Bye.
Bye everybody, thank you for coming.